Hi everyone, in this video we'll continue with the antenatal screening by looking at the different patterns of inheritance which determine how the genetic disorders can be passed on to any offspring. So as part of the genetic screening or genetic counselling, what you'd be expected to do there is to draw, analyse and interpret any family histories over at least 3 generations to establish the likelihood or the percentage chance of passing on a genetic disorder. So the patterns of inheritance you need to be familiar with are autosomal recessive, autosomal dominant, incomplete dominance, and sex-linked recessive gene disorders. You'll also hear a number of genetic terms and be expected to use them, describe what they mean. Those are alleles, so the different versions of genes, the different traits. Dominant, the allele which is expressed. Recessive, the allele which is suppressed. Homozygous, where the alleles inherited are the same. Heterozygous, where the alleles inherited are different. Carriers, the individuals without the disease but may have children that do have the disease. Genotype, the combination of alleles a person happens to have inherited. The phenotype, the characteristic that results from that genotype. Autosomes, autosomal, so chromosomes 1 through 22, and sex-linked, the X and Y chromosomes. So we start by looking at the autosomal recessive conditions. So here you've got a pedigree chart for PKU, which follows the recessive pattern. Just to note, this one does highlight the carriers, although that probably won't be something that you have in assessment. It'd be something you'd have to work out for yourself. But it's worth noting here is carriers only exist for the recessive patterns. So we can see that we've got our parents, neither of which have the condition, yet they have children which do. So the only way to get the recessive trait is to have 2 copies of the recessive allele. So we'll use the letter R to represent. So this individual here must be little r, lowercase to represent recessive alleles. So to get 2 copies, they must have got one from each parent. So each parent must also have at least one little r, recessive allele. Now to work out the second, we have to look at the chart again. So neither of these parents have the disease. So if they had a second recessive allele, they would. So we know that the other one must be dominant, represented by a capital letter. Let's do the same for the autosomal dominant. So in this case, as long as the dominant allele is present, the person will have the disease. So let's look at our parents again. So individual 2 doesn't have the condition. Let's use the letter H to represent this. So only way to avoid an autosomal dominant is to have 2 recessive alleles. So individual 2 can only pass on recessive alleles to their children. Therefore, if their children have the disease, they must have got the dominant copy from the other parent. Okay? So heterozygous individuals plus homozygous dominant would express the disease. So to have an autosomal dominant condition, you must also have a parent with the condition. And if you do, there's a 50-50 chance of inheriting. Let's move on to the sex-linked. These are a little bit different because now we must take into account the sex chromosomes. So if you do have a sex-linked pedigree chart and assessment, I recommend starting by writing out the sex chromosomes for the individuals involved. So XX for female, XY for males. Then work out the alleles and write these next to the X chromosome. We're only looking at those carried by the X chromosome. So here we've got an affected male and an unaffected female. Okay. So when it comes to females and sex-linked charts, you apply the same rules that we've already discussed for recessive and dominant, depending on your example, whereas males will be treated a little bit differently. Because males only have one X chromosome, they either inherit the faulty allele or they don't. So males 50-50, females the normal rules. So if a female does have the condition, their father must have it, but it's more likely to affect males than it does females. Okay. So let's look at this example where we've got an unaffected father now, but a carrier mother. Okay. It's impossible for this combination to result in female children with the disease, but their male children will have a 50-50 chance of inheritance. The last example then is incomplete dominant, where you've got two alleles but neither is completely dominant over the other. So this results in the heterozygous individuals having a sort of blend or in-between phenotype. So let's take the example of sickle cell anemia. So if you get two copies of the H allele, you have no disease. If you get two copies of the S allele, then you have all these misshapen red blood cells and have sickle cell anemia. However, if you get one of each, one H, one S, you have this in-between state where half of the red blood cells are normal, half have this sickle shape. So yes, you still got a disease, but a less severe form. And this would be an example of a pedigree chart showing you your incomplete dominance. So let's try some past paper questions on this topic. Pause the video and then select your answer. In this example, we're told the inheritance of the allele for deafness is shown in the family tree. The condition is crowbine allele, which is... So the answer is D, recessive, and we know this because neither parent have the condition, but they have a child that does. And we know that it's not sex-linked because we've got females with the condition, but the father does not have the disease. Let's try some more. Again, pause the video, hit play when you're ready to reveal your answers. In this one, we're told ADE deficiency is autosomal recessive, affects the immune system, caused by a mutation in the gene that codes for this enzyme. First, you're asked to describe the difference between an autosomal disorder and a sex-linked disorder. Okay. So, lots of options, different ways you could phrase this. You say autosomal is not located in the sex chromosome, where sex-linked is. You can use chromosome 23 as this is the sex chromosomes, or the disorder is located on an autosome, while sex-linked disorder is located on the sex or X chromosome, or autosomal disorders affect males and females equally, while sex-linked disorders affect more males than females. Apologies, let's go to part B. Again, we've got two pedigree charts, and you're asked to state the genotype of individual P using the letter A. So P is an unaffected male. He has a child with the condition. So his allele, he must be heterozygous. We've got one recessive allele from each parent, and because they don't have the conditions themselves, their second allele must be dominant. Okay, so big A, little a, and remember, if they do give you a letter to use, please use that letter, as in this case it says to only accept answers using A. So I know this can be a really difficult topic at first, so if you do have any questions or anything else you need cleared up, please let me know and I'll try my best to answer.